Hey, what's up, guys? Chung here. Uh, Today I want to talk about this problem. 1504 count submatrix with all ones. This is one of the problem in last week's in this week's week contest, right? So I find this problem really interesting because I haven't seen this kind of problem before, so it gave me really hard time of doing it. But so now I'm trying to share my thoughts on this problem. Hopefully, you guys can also learn something from this problem or this kind of question. Okay, so you're given like a 2D matrix. You have M and N, right? M by N matrix, which consists only for of zero or ones, and you need to return the numbers of all the submatrices with all ones, right? What is the submatrices with a submatrices? The definition of that is let's say for example this one 1 0 1 1 1 0 1 1 0, right? So the output is 13. Why, right? Because so there's no size limitation for the submatrix. You know this one itself will also be counted as an answer here. So basically they're like for one, right? For one, there's like six, 1, 2, 3, 4, 5, 6, and then for the other rectangles, and this one is also so for for one for 1 times 2 rectangles, we have two, uh, 1 and 2, right? The other side for 2 and 1, they're like 3, 1, 2, and 3, right? And for 2 times 2 there's 1, that this is the one, and for 3 times 1, this one, 1, 2, 3, right? So okay, so that's that, but how can we solve this problem, right? I mean, it's- okay, the idea here is that every time we'll be fixing like a number here, we'll be fixing a number here, right? Let's say for example, if we fix this number here, if we fix this number, and we're trying to expand so basically all the rectangles will be including starting from this point, right? And then we're trying to going downwards, right? Going downwards here, and then we're going down here, and so for example this one, so at this moment, let's say there are like only one the length of this the length of the first row will be one, right? And then we'll have one here. And then when it expands to the second row here, right? Okay, so when it's on the second row, basically we're trying to expand this this uh this rectangle at this point to the second row, right? And then from second row we see, oh, it has two numbers. It has two ones. But can we use both of the two numbers? No, right? Because in order to form like a valid regular rectangles, all the width has to be the same, right? So that in this case we can only use uh, one uh, one numbers from this second rectangle, right? Second row. So that's also one, right? And then for the third row, same thing, right? Same thing when this one expand to the last row here, still same thing because it's bounded to the minimum of the width here. So on the third row will also be one. Okay, and then let's basically we choose the upper left corners one by one, right? And then we plus one, and then we scan all the rows here. So zero, we simply ignore it. For one, this is simply just one, right? There's nothing here. We try to use this one as left upper corners, but then down below there's nothing to add, right? So that's simply add one. Okay, now, okay, let's say we are at this point. Now we're assuming, okay, we're trying to use this one as the top top left corners, right? And then we see, okay, with this one, uh, how many options I have, right? How many rectangles I can make with the first row here, right? That's it's gonna be two, right? Because the length for this is two, because we are not considering this one anymore, right? So for this one, we're gonna have, we see, oh, there's two ones, consecutive ones. That's why we can make two rectangles, right? With this one as a starting point, right? So because that's one, right? Second one will be this one. That's two, right? Remember, always remember, we fix the starting point. So any rectangles has to include this one, right? And then we come to the to this row here, right? Still remember, we are starting from here, right? We're starting from this one. We're starting from this left upper corner, and then we're trying to expand our rectangle. Now we're coming to this one. See, okay, we have two rows here, right? Okay, so we have two rows here and two ones here. And can we use both of them? Yes, because the minimum width of this of so far is still two, right? So with this one here, with this one included, we can also add two more rectangles, right? Which two? This one, the first one is this one. Remember that we all the rectangles has to include this fixed starting point. So that this is the first one we can add by including this row here, and the second one will be this one, right? So that's two. And then so and now we're here. We're at this point, right? As the starting point. Now let's see from this one. Now we're at this point. Let's say we scan this 2D matrix one by one, right? Now the starting point will be moving to here, right? Then what's that? What's that? Similar thing here, right? This is one, and if we try to expand this rectangle to the last row here, it's also one, right? And now we're at the last. We are using this one as the starting the fixed point right here, right? And then so with this one fixed point, same thing. First we have two here, right? That's all we have because that's one and two. And now the last one will be one, right? So that's the process. How many of those? One, two, three, four, 6, 8, 10, and 13. So in the end, we'll get 13. Okay. And so, right, so that's that. And about how to get the length of basically the how many ones or how many ones at this point, right? We can use a pre-computing, right? We use a pre-computing to mark this current element to compute how many ones on the right side, right? On the right side, and then when it's come to here, we can simply use that to retrieve how many ones uh, at this point. It's gonna be here. Cool. Okay, so let's try to code this thing. It's very to me it's a new kind of type of problem. Maybe you guys have seen this before, but for me this is my first time coding this. Yeah, that's why I want to share with you guys about this problem. Okay, so first step first, and we need to pre-computing the how many ones, right? Basically the consecutive ones starting this point to the right side. How, right? We simply do a loop, right? For first we do a I, okay, we do a m. We need to get the length, the 2D length, m, and n equals to length of mat 0, 0. So let's see the mat. yeah, so the rows and columns, they're at least one row and one column. So in that case, we don't have to check if this mat is empty or not, right? Do I in range range m, right? And then for the second loop here, right? Since we're going to uh, get the ones on the right side, let's do a reverse looping here. We just do a loop from right side to the left side, right? So in that case, we can check, we can accumulate how many ones we have seen, right? And if we see a zero, and then we know, okay, this one is zero. So basically, we do a n minus one and dot minus one and minus one, right? So in this case, we do a we do a reverse traverse. So basically, we check, right? If uh, uh, if matrix I and J is one, right? If this thing is one, what do? We do we do let's pre-sum one counts, right? So one counts to the array here. I think we can use the same. I believe we don't have to introduce a new space complexity here by creating a new 2D array. But in this case, I just to make this solution clear, I'll be using this additional space to store all the accounts of ones here. Uh, to its right, right? So it's gonna be the same 0 and the same thing here. 0 gonna be n, right? For in range m, right? That's how we define 2D array m by n, right? And then if this thing is 1, right, we do what? We do we can simply ideally we want to do what we want to do one counts, right? I and j uh, plus the y and j I j minus 1, right? Ideally, we want to do this because we want to accumulate the ones, right? And then else what? Else we simply do nothing, right? Else we simply do nothing because if it's zero for the current I and j, since we initialize to be zero, we simply ignore it, right? Otherwise, we just keep adding this ones to the next one. But here, and we need to do a like check here because j minus 1 might be sorry, j plus 1. I'm sorry, the j plus 1 because we're trying to get the ones on the right side, right? But here j plus 1 might be giving us like a, a out of boundaries here, right? So we just do a simple check here to only we add this only if the j is smaller than the n minus 1, right? Yeah, if right else 0, right? Else we can simply do a 0 because uh sorry, else just 1. Yeah. Yeah, because for the first one, let's say this one is 1 here, right? Let's say this is 1, and we cannot use this one because j plus 1 will be out of the boundaries, but we still want to so that we just simply set 1 here, right? Else otherwise we just use the previously uh value to set this thing here, right? So now we have a pre calculated array here. So let's see. So what's going to be the numbers in this one count here? It's going to be 1, 0, 1, and what about here? 2, right? 2, 1, 0, 2, 1, 0, right? Because we are trying to get, so at this position, there are like two ones on the right side, and here's two ones. Here 1, 1, 1, right? Because here there's 0, that's why this is 1 here. Okay, I'm gonna leave this like matrix here. So now let's try to do another loop, right? So the second loop will be try to fix all the corner, the starting point, right? For us to get all the sub matrices, the rectangles, right? Same thing here, right? For j in range n, right? And now we need to have a k here, right? So the k will be from the first row to the last row, right? Remember, because we're trying to scan it on the right side, right? So that's why we need to scan all the rows downwards. It's gonna be from in range in range uh m, right? In range m basically. Starting from I and to the end of the last row here. Okay, so we can do a simple if check here. I think if this thing is if the current mat is 1, then we do this. If it's 0, then yeah, we can simply just ignore it. If mat I j is 1, right? Oh, and I think, sorry, for each of the fixed element, we need to maintain a minimum you can call it like width or length, right? For the current for these big rectangles, right? So minimum let's call it width, right? Since that we're doing like from left to right. Uh, Width, yeah. Since we're going to get the minimum from it, so I'm gonna initialize with the maximum value here, right? And then so first, right, the minimum value. Let's see. So first we'll be getting the minimum value from the current counts here, right? So the minimum width will be the what? The minimum of the minimum width and the current value, and one counts here, right? One counts dot same thing I and j. I'm sorry, not I and j. The since we're at the case position, right? So it's gonna be the uh, k is the row number, so it's gonna be k plus j. Yeah, k plus j. So because we're going downwards, so basically the j is fixed, right? J is fixed, and the i is different. So the k, I'm sorry, the j is fixed. So the column is fixed, and but the rows is different. So that's why we use a k here. And then we simply do an answer because we need to get the answer in the end, right? So let's do a answer equals 0, right? So now we have the minimum of the until now, right? And then we can simply use this minimum value to add it to this array, right? That's the new rectangles we can get by extending this array into this point, right? So it's gonna be a answer plus just plus basically the minimum width here, right? So I think that's it. So in the end, we just return the answer here. Let's see. Oops. Okay. Let's see. Did I do anything wrong here? Like, let me check this one. Maybe something is wrong here. I want to check if the one counts array is correct or not. Yeah, I think this is wrong. So I think I made a mistake here. Let's see. think I was too young, too naive by writing this simple lines here. I thought this should work, but no, it didn't. Let's see. Uh, I think I know what happened here. So here we always need to plus one in at the beginning here, right? And then house zero. This should do it. Yeah, because we need to at least plus one, and then whatever left is coming from the rest of these things here. So if there's nothing on the right side, we simply assign zero, right? This should work. Mm, no. Let's see. Oh, sorry. Here, we need this like parentheses here. I think this should work. Yeah, cool. So let's cross our finger. Yes, nice. Works. Yeah, weird. I beat 100%. Don't know what happened to LeetCode. I think LeetCode has some issues with this like uh submission here, like how many people you beat. I think it's most of the time it depends on your internet speed or something. I'm not sure. Cool, it passed anyway. So let's get back to our code. Let's revisit one last time. So in order to fit to calculate this sub matrices, right? Matrices or the rectangles, we will pre-calculate how many consecutive ones starting at this point on on the right forward, right? That's what we're doing here. We're trying to pre-calculate basically the width of ones starting this point, and then once we have that pre-calculated, we just loop through each of the node uh, to be the starting point of all the matrices, right? And then we try to expand that matrix from from this position downwards, right? Because that's how we can make sure uh, that's how we try all the matrices, all the rectangles starting from this point, right? And then in order to do that, since it's bounded to the, in order to make a form a valid matrix or rectangles, all the rectangles has to be have the same have the same length, right? Yeah, and that's why we do this minimum width of this. I think here we might not even need this check here. You know why? You know why? Because let's say if there's like yeah, actually the check shouldn't be here. The check should be outside. Yeah, you're right. So the check should be outside. If this thing here, if this, yeah, yeah, right. And then we run this. It should also work. Yeah, I think LeetCode has some issue today. It's always like 50%, 100. So we do a if check here because but I think if even though we remove this one, it still works because in that case, let's say if this mat, if the current value is zero, what does it mean? It means that the minimum width for this for all the matrices starting at this position, it's all they're all zero, right? So that we're basically adding zeros over and over to these answers, which will not affect the final result. But we do a if check here just to save the for loops from here. But it doesn't. It's for the final time complexity calculation, it won't make any difference, right? So let's take a look at what's the time complexity here, right? So first, that's the m times n, right? So here is the m times n. How about here? M times n, right? To try each of the one as the as the uh, as the fixed point, and then from here we loop through each of the row here, right? So it's going to be another m, right? So the combine these two, so the final time complexity is going to be m2, right, times n, right? And how about space complexity? Pretty straightforward. O m n, right? Okay, cool guys. I think that's it for this problem. For this problem, you can either do it in this way, because here I'm doing this from left to right. You can also count it from top down, right? So basically you rotate. You can rotate this. You can rotate this because here I'm counting it like this, like to this side, right? You can also count it. You rotate this thing by 90 degree, right? Then you count it like this, right? And will be more like a graph, right? So basically you a graph here, but here it's like on horizontal, but here's vertical. You can use either way, but the concept here is the same, right? You use the lower bound of the width. In this case, it's width, but if you do it in this way, it's going to be lower bound of the height, right? To calculate all the sub rectangles. Okay, cool guys. I think that's it for this problem, and thank you so much for watching the video. I hope you guys enjoyed, and at least I did. Yes, I like doing the lead code while also explaining this problem to you guys, and yeah, I hope both of us can learn something from this problem. Cool. Thank you. Bye bye. I'll be seeing you guys soon.